talk about the similarity postulates. They're just like the shortcuts we learned for congruence. Remember, like angle, angle, side, and side, 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 and angle, side, angle, and all those for congruence. Well, there's 3 shortcuts for similarity, too. We're going to learn those shortcuts. We're going to apply them just like we did for congruence. Remember, I do pictures and you had to tell me what shortcut it was. And then we're going to use those shortcuts to solve for missing pieces of other triangles. Okay, so the 3 shortcuts are angle-angle similarity, and that's if you can prove 2 of the angles of 2 figures are equal. That means they're similar. Okay. Why do we have to prove that 3rd angle? Why is it just angle, angle instead of angle, angle, angle? Right, exactly. It's called the 3rd angle theorem, right? If 2 angles are already congruent, then that 3rd one also has to be congruent. So we only really have to prove 2 angles are congruent to prove the triangles are similar. Then we have side, side, side. And in this case, the sides aren't congruent. They have the same similarity ratio, so they're proportional. Okay, and then side, angle, side, which is 2 sides are proportional and 1 angle is congruent. So we have angle, angle similarity, side, side, side similarity, and side, angle, side similarity. Okay, 2 angles, 3 sides, or 2 sides and an angle. And the angle has to be in between the 2 sides. All right. Let's start with the first one. Do we know any sides? Do we know the measures of any sides to tell if they're proportional? So which shortcut do you think we're going to use? Angle, angle, right? So right now we see that the right angles are equal. Let's label these A, B, C, D, F. So we have 1 angle congruent, but are these 2 angles congruent? No, but let's check. What would the measure of this angle be? 47, right? 90 plus 43, and then subtract that from 180, and you get 47, which would make this one 43. So now do we have 2 equal angles? Yeah, like the 47 and the 47, right? So by angle, angle similarity, these triangles are similar, and the similarity statement would be triangle A, B, C is similar to triangle, and then I use, I have to match up the angles, so what goes with A? F. What goes with B? Yeah, B and D, and then C and E. Okay? Okay? How about the next one? We have some sides. Do we have any angles? Don't forget so quick. What kind of angles? Vertical angles, right? Aren't these 2 equal? Only if we knew TU and VW were parallel, and it looks like they are, but they didn't tell us that, so not for sure, we don't. Okay? So if I can prove that sides are proportional, then I could use what shortcut? Right. So which 2 sides should we match up together? Should be 15 and 16 and 12 and 20, or 15 and 20, 12 and 16? Yeah. Always want to match up, because it could have been 15 and it could have been these 2 and these 2, but I always match up the smaller and the smaller, the larger and the larger, because is there any way they're going to be proportional if you match up the smaller and the larger to the larger and the smaller? No, that'll never work. So you're setting yourself up for failure. So I match up the two smaller and the two larger. Okay? And then I cross multiply and just see if it works. 20 times 12 is 240. And 15 times 16 is 240. So are they proportional? Yeah. The other way you could have done it, right, is reduce these two fractions and see if they reduce to the same number. And they do, right? They're both 3/4. So either way. So I've got side, angle, side, similarity, which means triangle, TUX, is similar to triangle. What goes with T? What side is along the long line over here? V, W, X. Okay? So there's an example of angle, angle. There's an example of side, angle, side. All right? This one, I think I might have erased all the letters. A, B, C, D, E. I think these are kind of hard just because it's a little bit challenging to find the triangles. So the two triangles we're going to use are ABE, that triangle, and CAD, that triangle. Okay? Some people try to do ABE with BECD. What would be wrong with that? This is a triangle. What's that? Trapezoid. So they're never going to be equal because they're not even the same shape. So I have to do little triangle inside and then big triangle outside. Okay? So I've got one angle that's equal. So that's good. So I can either use side, angle, side, or angle, angle, because I'm not going to use side, side, side if they gave me an angle, right? Do we see anything else? Right? We have a base, 8 and 12. So that would be a proportional. There a proportion. Do we have any other sides, though? No. So do we have another angle? Remember so by the reflexive property, angle A is equal to itself. So what's my shortcut going to be? Angle, angle. Good. So even though they gave me a side, they didn't give me two sides, so there's nothing I can do with it. Then I would do triangle ABE is similar to triangle. A goes with A. What goes with B? C and D. So triangle ABE is congruent to angle ACD. Okay, and the last one. We don't know any angles, so what do we think it's going to be? Side, side, side. Okay, so we got to set up a proportion, see if they're proportional. So what measurement does 4.5 go with on this? 3. So 4.5 and 3 for the other side. And 3 and 2. Okay, and then I do cross products. 2 times 4.5 is 9, and 3 and 3 is 9. Are they proportional? Yeah, because the cross product's equal. And ordinarily, I would have to check all 3 ways, but these are obviously proportional because they're the same. And once I check one of them, the same products are going to be the same for both. So that's done. So does that make sense? Why you only have to do it that one for this example? Because ordinarily you'd have to check this side and this side, this side and this side, these two sides. You'd have to check them all. But in this case, since these are identical, you don't have to check one. Yeah. Yep. Exactly. And then triangle, SUT, is similar to triangle, RPQ. And then last but not least, what I said, well, we're going to identify shortcuts, and then we're going to use those shortcuts to solve for missing sides. So first of all, are these triangles similar? Why? They have two similar sides. What are they? So, like the 18 and 6 and 5 and y, though? Well, do we know what y is to prove that it's similar? Well, that's kind of putting the chicken and the egg thing. Like until they're similar, we can't solve for y. So we can't use y to prove they're similar yet. But is there another way? Well, there's one side, 18 and 6, but do we know enough of any other sides to compare that proportionally? So angle, angle. So we know these two angles are equal. Do we know another angle? Yeah, isn't that they share that angle, right? So angle, angle, they're similar by angle, angle. So A is easy. If that's 34, what's this one? 34. Okay, how would I find C? $33, 34 plus 37 or plus 77 is, oh wait, 11. I was multiplying. 11, 5, 6, 61. Right? Oh, that's a 7. 10, 11, 111. Subtract that from 180, and you get 169 or 69. Is that right? Okay. So if C is 69, what's B? 69. They're the same, right? Angles are congruent in similar triangles. All right. We know one ratio is 6 to 18, and the other ratio is 5 to y, right? So I get 6y is equal to 90, and y is equal to 15. So I know y is 15. And now, how do I find x? Anybody? Ahmed, how would I find x? This side. X. So these are the three that work with similar figures as well. So even though we had lots of them for congruence, these three work with similar.